Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 12th. The chapter that we're dealing with is integrals, and now is the turn of exercise 7.5. Now this particular exercise is based on an important method of integration, which is called integration using partial fractions. Now for some questions which are algebraic, let us say algebraic functions, so how do we integrate those algebraic functions? Furthermore, some functions which can be converted into algebraic functions, and how do we integrate those particular functions, right? In particular, we'll be talking about rational functions over here. Now what kind of rational functions are we talking about? Something related to polynomial upon polynomial. This is what you look at, polynomial upon polynomial, and in that also the degree of numerator and degree of denominator, we should be looking forward to solving. Degree of numerator is lesser than degree of denominator. Now in case that is called a proper rational function right now. So in case you get a degree greater than the numerator, what do? You use a long division and you divide the numerator with the denominator. You get some quotient and you get some remainder. So remainder will come on the top, the quotient will be left on the side, and obviously the degree of remainder will be less than the degree of denominator. So that particular rational function, proper rational function, is what we'll be learning to integrate in this particular exercise along with the questions one by one, right? So in the method, the first and foremost important thing is to convert any proper rational function as sum of partial fractions, right? To write it as sum of different fractions. The fractions in themselves will be easily integrable. That's what we are looking forward to, right? So along with the questions, we'll be seeing the method to convert into partial fractions, and then we'll be integrating those partial fractions, right? So one by one, let's move on to the questions. First question says that integrate the rational functions in exercises 1 to 21. Okay, so the first one begins with x upon x plus 1 times x plus 2. How do we handle this? So the first thing that we are supposed to do is, okay, we have x upon x plus 1, x plus 2. So let's begin with this, x upon x plus 1, x plus 2. This is similar to, this has two linear factors in the denominator, right? And degree of numerator is less than degree of denominator. Those two things have been checked, right? The denominator is factorized and the degree of numerator is less than degree of denominator. If these two things are there, then we can move to the next step, right? So first step, is the degree less? Yes. Second, is the denominator factorized? Yes. Okay. So first, degree of numerator is less than degree of denominator. This is important, right? If that will not be the case, then you'll have to use long division and divide first. Second, factorization of denominator into linear and quadratic factors. Right? This is important. Denominator has to be factorized into linear and quadratic factors. In that case, we'll be dealing with this particular method, right? And after that, we'll be converting into partial fractions. And then integrate. Right? So how do we convert into partial fractions? The conversion into partial fractions involve these few steps. What are the steps, right? You write it as a separate term for x plus 1 and a separate term for x plus 2, and you actually write it as a upon x plus 1, some coefficient with x plus 1 and some coefficient with x plus 2. Target is to find the values of a and b now, and such that this is always equal to this. Okay, target will be to find a and b such that this is always equal to this, implies that this is an identity over here. And how do we deal with that? So there are some shortcuts, yes there are, but other than that, when we take a look at this, what do we say? Okay, let's write it as, let's simplify this over here, and to find the values of a and b, we are writing it as this, and this tells me, okay, a times x plus 2 plus b times x plus 1 is there in the numerator. Okay, if the denominators are equal, therefore the numerators have to be equal, x equal to a plus b times x. Do you observe the numerator over here on the right hand side? Yes, ax bx will be a plus bx, 2a plus b will be extra. This is 2a plus b extra, right? And by simple comparison, since this is always equal to this, by simple comparison, what do you say? that a plus b, this coefficient of x over here should be equal to coefficient of x over there. This is equal to 1. And moreover, this 2a plus b, this 2a plus b over here has to be 0, as you see over there. There is no constant term. This constant term has to be 0, right or not? Yes. Okay, let's subtract these two, and what do we get? 2a minus a will give me a, b minus b is gone, is equal to minus 1. And b is equal to 1 plus 1, 2. This is what you get, right? This is what you get. So a is equal to minus 1, b is equal to 2. This is something which I have obtained. Therefore, we can say, therefore, I, the integral of x upon x plus 1 times x plus 2 dx is actually equal to integral of a, which is minus 1 upon x plus 1, minus 1 upon x plus 1 plus 2 upon x plus 2 integral of this particular expression. Now take a look at this. This should be always equal to this. Yes, this is an identity kind of thing. Yes. And let's simplify this. This is minus x minus 2 plus x plus 2, right? Sorry, plus 2x plus 2. So minus 2 and plus 2 will get cancelled. 2x minus x will be actually x in the numerator. This is always equal to this, which you can see by simplification also. And that is how we have actually calculated the values of a and b. Okay. And once we reach this stage, do you realize that integration of this and integration of this is very, very simple? Yes. And that's the key. So this is minus integral of dx upon x plus 1 plus 2 times integral of dx upon x plus 2. This is what you have. And this becomes, the integral becomes log modulus x plus 1. There's a minus over here, right? For x plus 1, the coefficient of x is simply 1. So that will come in the denominator. That's not important. Plus 2 times log modulus x plus 2 plus constant term. This is what you get, right? So you can leave the answer at this stage, minus of this plus 2 times log of this, or you can combine the two logs, and write it as, okay, this 2 will go over here in the power log of x plus 2 square and minus of log x plus 1. So this will become log of x plus 2 square upon x plus 1 and its modulus. This is the expression within the log plus constant term. This or this, any of these forms are okay, right? So that's the final answer for this particular question. As you can see over here in this question, the steps, mind you, first observation over here works because degree of numerator is less than degree of denominator. That's just something which should be there for a proper rational function. Denominator should be factorized into linear and quadratic factors, and after that we convert into partial fractions. Using those steps, then we integrate easily. Right? That's the complete solution of this first question, as you can see over here.